Hi, hello everyone. So I'm very happy to be giving this talk today, since this is a topic that I have been interested in for quite a while. I was fortunate to be among people who were sort of like early testers for one of these models. And since then, that was a bit more than 2 years ago, a lot of my focus was in this area. However, since I know that probably you're coming from a bit of different backgrounds, I'll just do as a brief introduction, just a kind of video, because I know some of you have seen this. Some of you maybe didn't pay that much attention to it. So you will see here a very brief example of some of the things that have become possible just this last year. So basically, now possible, of course, to write something and then get an image based on this text, but also more than that, to simply replace an image by writing text, or to extend the image, and so on. So of course the question is what actually occurred. I mean, what was it that made this all possible? Before we go to this, I have prepared two statistics that really illustrate the great extent of change that is happening now in this field of generative AI. So first of all, if we look to the left side, so someone has posted this on Twitter, as you see, not long ago. And it's actually a timeline, how long it took for these various models to get to 1 million users. So we see that the GPT-3 actually needed almost 2 years to get to 1 million users. And then their coding assistant just half a year. Then for this image generation model, DALL-E, it was just 2 months and a half. And now this latest edition, ChatGPT, which was only released last week, has reached 1 million users only in 5 days. And to the right-hand side, it's a bit of a different story. So obviously, when it comes to AI topics, there is a lot of discussion, what is hype, what is not. And another technology that is often subjected to hype, of course, is the blockchain and cryptocurrencies. So I do hope none of you are maybe offended in any way for me to show this graph. I know it was a very turbulent period for blockchain recently. However, you see here, and let's go a bit over the colors. So what this chart shows is how many stars are given on GitHub repositories for all of these important libraries. So we see how for Bitcoin, the growth was since it was first published, and then for Ethereum, the yellow one. So PyTorch is one of the main machine learning libraries today. So basically, it's good to have it here for comparison. And the transformers library is basically what technology that is driving a lot of these changes. And so here is this anomaly. It's a model stable diffusion, which was released only sometime in mid-August, and has really had this vertical growth, which I think it signifies that we are living now in a bit of a special time when it comes to this technology. Yeah, so now to give you a bit of a broader picture, what are some of the trends that are actually driving this? Why is this happening now? So, well, I think that the main factor here is simply the scaling of these models and of compute. So here on the right-hand side, I have this separation across different periods. So basically, about 2010, this era of deep learning started. So basically, models based on deep neural networks, and they were, of course, quite demanding in compute. So what we are seeing here is how much computation is required to train some of these most well-known models. However, around 2016, or maybe a year later, it depends how we look at it, what we saw is this emergence of really very, very large models. So models that no individual could, except maybe some of the richest people, could train, or their own infrastructure. So it's something that is driven by companies. Also, what we are still seeing is enormous growth in innovation. So this number of papers that are being published continues to grow exponentially. Even some of the people who are most active in this research community are starting to complain that this is becoming impossible to follow up. But of course, it's always a question: if we need more and more compute to achieve a certain result, is this really growth? Or maybe we've just reached a point where it has become so hard to compute something that we need to put this type of resource into it. However, that's not really the case. And here on the bottom right, I have the charts which are showing how basically on the y-axis is, you can imagine it as the error of this model. So it's lost, but you can imagine it as an error that they achieve when they are tested. And here on X, we have first increases in amount of compute, then increases in amount of data that is available for training, and then, of course, also the number of parameters that these models have. And so what we were observing during this period, the last one, is that as we scale all of these resources, the loss continues to fall, and it is happening quite predictably, actually. So this is why, of course, more and more organizations are now investing heavily, since they have something that they can use to predict how the trends will continue to go. All of the models, or most of them that I will mention during this talk today, are basically something that is now called a foundation model. So this is why I will just point out a few of their properties to put it into context. So a foundation model is basically a model that has been trained on really a very vast amount of data. So in some cases, for these language models, people are even saying that practically all of the text that was scraped at some point from public resources on the web was used. And also the number of parameters for these models is very large. So these are like their individual neurons that make then these large neural networks. And also the amount of compute, of course, goes into the thousands of GPUs for these largest labs that are working on these models. So what is really interesting with these models is, I would say, maybe firstly, that they are multi-purpose in some way. So after we train them, we can use them to solve quite a few different tasks without requiring further training. In some cases, they can even cover different modalities. So it means work on both images and text and so on. Also, most of these models are generative. Basically, they generate content instead of just, for example, extracting some insight about it. And this third property, and for this one, we can see this chart here, is called emergence. And what was noticed was that here we have the opposite situation. So here now we don't have error, we have accuracy of these models. And then it's a model scale, so how much compute we invest into them. And so what was noticed was that for a lot of these models, we might see, stagnation as we increase the scale. It doesn't seem that they are able to perform any better by us increasing the number of parameters, but then these sudden jumps occur. Suddenly, a model gains some capability that simply emerged at a certain size, and it wasn't there before. And it's proven quite challenging to predict when or whether such a capability might emerge. Also interesting is that these models really, they are more or less all of them based on transformer architecture, which has really proven transformative. This here is a bit of a caricature, though. It's not that it's exactly the same architecture, but it's still a very similar one. And also very importantly, when it comes to their use, after these models are trained, they require very little data to actually do the predictions. So we call it zero shot, when basically the model can provide some output simply based on instruction without requiring any input data, or sometimes we need to show it a few examples to do it. And the last thing, which is also driving this widespread adoption, is that a lot of these models have become such that they're really very easy to use. I mean, for certain cases, and it doesn't require some niche specialization. And hopefully this is also something that you will see from this presentation today. These foundational models were actually the term was mostly developed with language in mind. So because these were the first models of this size that became available, that they started to make a difference. The company OpenAI was in some way a first mover here. I mean, not that none of these models existed before, but it was their model GPT-3, which really achieved a certain level of performance that was very impressive. So this happened in 2020. And since then, as you can see on this image here, they got, I mean, a lot of other models appeared. Some of them are proprietary, accessible through an API. Some aren't even in any way accessible, while others are open source. However, and here I'm speaking more from my opinion rather than fact, but still I feel that they do keep an edge, and that the family of GPT-3 models is the most, I would say, practically useful, especially when it comes to business context. And also I found very recently there was an analysis about performance of a bit of wider set of these models on the same benchmark. So here we see that this GPT-3 Da Vinci, this was actually the model that OpenAI released in 2020. And since then, some competitors were able to surpass it, at least when it comes to this number. But at the top is still Da Vinci version 2. But as some, or even maybe most of you know, just recently number 3 was released. So this is still GPT-3, but just a subversion 3. Which again is quite a bit more capable. So possibly it's hard to predict where it would fall here, but for sure it would be better. And one reason why these models perform so well are that they are one of very few currently accessible that were trained with human feedback. So in general, these models are trained simply by trying to predict the word that comes next in a sentence. And if we have a lot of data available, then they able to kind of get a representation of the world around them in order to be better at predicting this, what comes next. However, there is also an approach where we can show these, what the models generate to people, and people rank these outputs, and then basically there exists a feedback loop where the model tries to generate things that are more aligned with what the people would actually like to get after they put some input into the model. I believe that this gives a considerable edge, at least for all mostly practical use cases. So that said, let's maybe take a look at one of these models. Yeah, so just give me a moment. I have many windows open. Hopefully you see it well. Maybe one thing I forgot to add. So the idea is that at the end we will have a bit of a Q&A session. So I know it's sometimes hard to remember at the end what some questions were. Please write them down. I will try to cover as many as I can, but for sure it's better if you simply post them in between. I know this format doesn't have the sound from the other side, but questions are very welcome. Yeah, so here, this is what it is called a playground for the OpenAI series of models. And here is what I mentioned, right? The text Da Vinci 3 model. I have this example that I often show, or yeah, maybe I will do this one, right? So this, I do want to talk a bit about creativity, right? So you can definitely use this model in such a way to help you think of some things. And a while ago, I was showing this example, but the model was less capable then. So let's see what sort of product that nobody really needs it comes up with, right? Okay. Some of them maybe even have some sense in them, but just so you see the dynamic here. So basically, the model gets this, and this initial part, we call it the prompt. And then it actually tries to predict like what comes immediately after the prompt ends. But of course, since it saw so many things on the web and elsewhere, it is able to produce coherent outputs. And you can generate basically all kinds of things with it. But it's not just about generating, like giving these ideas, it's also transforming text from one form into another. So, for example, you might have, let's see, I had this earnings example, right? So you might have a document, a lot of text. It's a transcript from an earnings call. It's from Endava 2 quarters ago or something like that. And the idea is here that you can transform this text in many different ways. So, you can just say like summarize in 5 bullets, right? I noticed it's working a bit slower today because simply there's so many people testing this out now, and it's able to do it. And after you have it here, for anything that you see in this prompt, you would be able to ask it questions and so on. But let's maybe let me now show you this other thing that came out, and hopefully it will work. You see, it's even saying, "Are you looking for ChatGPT?" Let's try it. So first of all, what is the difference? It's actually underneath, most likely it's the same model. However, for ChatGPT, it has been tailored a bit to be more in the chat mode rather than be something like a kind of text editor. And you can really consider it as a kind of assistant for almost everything. I feel that one of the biggest use cases is for educational purposes. So not just finding out some information, but even saying like prepare me or maybe I will increase the size a bit. Otherwise, I don't know how well it's seen. For a 10-hour course in large language models, it should be accessible to beginners. Like I said, it is a bit slow because these millions of users is really showing, but still. So it is able to provide something. It takes a while to read, of course. In most cases, it does quite well. So I guess it's very useful, especially for things where it is easy to check whether what was generated is actually useful or factual. So things that it would take us a lot of time for us to come up with this idea, but after we see it, we can verify that it makes sense. But we could also ask it now for lecture number 4, suggest some homework assignments. And since this is the bot, it's a kind of conversation, and it is able to have quite a long look back into the conversation. Yeah, and Also, of course, let's see, now we are moving, I guess, to this part that is especially relevant. It can also communicate with code, right? So you could ask it like, write tutorial working or working with, I just say like large language models in PyTorch and provide code examples. Yeah, so I will talk a bit more about the code down the road. I just wanted you to really see that, of course, the code is not always correct, but it has gotten much better to what we were able to see from this family of models just not that long ago. So I will be showing a bit more examples later, but just wanted to make some points here. How to get the most out of these models in practice. So obviously, as you can imagine, you can spend a lot of time trying out various things and generating, but it's clear that the models do have some deficiencies. So for example, one thing that they are not really good at all is mathematics, any kind of it. Maybe, like adding small numbers, very small ones, this works, but if you go and ask them to multiply large numbers or things like that, it kind of breaks down, right? But here is one interesting thing that I feel that it's one of the most important things when it comes to these models down the road. And so I want to share this example with you. Yeah, so let me zoom in a bit. So this is a kind of a application on Replit. It's a nice environment to look at the code and execute it on the right hand side, but still. So what's interesting here is this instruction. So basically, most of the code actually for this model is the so-called prompt, right? And in this prompt, we actually tell the model what we already know to be true about it. So we say that you are GPT-3, you can do math, you can do basic math, but you're not that good at, calculating it. And also there's this other tendency that you forget which date it is, it kind of makes sense because these models are not trained in real time. So basically by itself, the neural net doesn't have this information encoded somewhere, but we can point it out. And one interesting thing is now that we say to the model that we will be giving it access to a Python kernel, so it is able to execute code. And if it gets a problem that it's kind of a hard math problem, or at least it judges it to be hard for it, it can simply use this kernel to write some code and execute it, and this way help itself to get an answer. So basically, if you ask it something very easy, it will probably answer directly, right? So the neural net didn't I mean, obviously there should maybe not the right word, but didn't decide to go with the code. But if we say like multiply so the interesting thing happened here now. Basically, the model realized that it will not be able to answer something like that, according to this initial instruction. And so it wrote this code, which then was evaluated, and we got the answer. And this is a very key concept, because in such a way, we are able to address like the biggest deficiencies of these models. So I never was one of the people who thought that this model is an oracle, that it should be always right. I saw it as something in between, a kind of a gateway, maybe from, it can be from an idea to the final implementation of the idea, or from one interface to another. And now that they have achieved this capability, and also if we ask it like which date it was 5 days ago, and yeah, you see again, it even knows to, of course, to import the necessary library and checks the system time, does the calculation, and provides the answer. But still, the model is still here. It's limited to what it can do here with this code. We can go a step further, though. I have another example here. Just a moment. This one. Yeah, it will take a moment to load. So the question is, of course, how far can we push this, right? I mean, does it just work like that we just list a number of tools and we say, if you want to calculate this, then use that? I mean, this doesn't sound so good. I mean, it sounds more like some people are joking that it's all if sentences forever. So this example, again, most of the instruction is contained here in the prompt. It goes like that basically, if we tell to the model, if it gets a question, it has two functions additionally available. So this read vec page enables the model to read text from a website. And this ask GPT-3 actually means that we give it the ability to ask itself. So when it feels that the information is such that it's best to ask itself again to answer it, it has this ability. And it's kind of, if the question is very easy, then just answer. If there is some data, we say that, acquire it through this library if you need it, and if you need some code, then just write the code. Yeah, then of course, here some examples are given. If you remember, I said that in some cases, these models are 0 shot, sometimes there are few shots. So here we give it a few examples, like 4 or so, just to show it how this might go down in this type of reasoning, right? So for example, let's say that model gets a question, how much does the house at this address cost? And then we give it the ability to do a Google search for address, and out of this, it's you get the link, and then the model, and here is the interesting part, it asks itself, after it sees the URLs, which one seems like it was most likely contain an answer. So let's give it a go. So maybe let's ask it. I'm thinking for let's try. Who is the CEO of Endava? Okay, so here in this debug mode, you see the steps it takes. So first, it gets this idea to go on Google and search Endava CEO. And then it asks GPT-3, based on the URL that it receives, to guess which of the URLs is probably the best one. It goes then to this URL, it reads some text, and its answer in the end is, it's not entirely certain, but according to the management team page on Endava website, it seems that John Cottrell is the CEO of Endava. So this concept, it's really, when I first saw it, it was kind of mind-blowing for me, because it really opens up the field of applications for this in all kinds of directions. So, but it's not still, I would say, not a lot of focus is given on this particular area. Or now let's try maybe, I don't know, will this work? So how much was, yeah, so what is the price of Microsoft stock? That's right, so it's not always Endava. Oh, yeah. Okay, let's first see the logic, and then we'll go. So first, it thinks that to find the right ticker, and then after it gets it, it wants to use this pandas data reader to access the application, the information through Yahoo. But and then if this part would actually work, so yeah, there's actually no reason why the model would think it's not working. But I think that it's something is broken with this data access. But the logic that the model has is correct. It's just that the code appears to be broken. Yeah. So let's jump back to the presentation a bit. I will skip this one because I will return to it a bit later on. But there's this of reasoning. So I mean, if you saw these examples, you probably thought that maybe these models do have some sort of way to reason, or at least it's some nice trickery. But the tendency is, if you use these models out of the box, you will get a lot of wrong conclusions. And it's, again, one of the kind of biggest downsides. There was a lot of talk, actually, that they never will be able to reason based on this current architecture. Until a while ago, a paper came out, which was a very strange paper, maybe a strangest one that I've read until then. So I think it's really worth mentioning it. And so this paper was trying to find solutions for this type of problems. So this like small mathematical problems that are contained inside the text. So the model would get this question and then the answer. And of course, it would immediately try to answer, and usually it would be wrong. Actually, it was right only, it says here, right, 17% of the time it was still correct. And so basically all the authors did was they added this, let's think step by step, to this initial instruction. And it's incredible how much the results improved. So here on the right hand side, you see some of the terms that that were also used and tested. And it went like from 17% accuracy to 78%, with some of them working better or worse. And it was not just on this data set. Actually, this thing step by step, I'm showing you this because if you ever use these models and would like to have a bit of reasoning from their side, just write this thing step by step. It will, in most cases, it will work better. And I mean, it's kind of strange to me. It was really bizarre even, but yeah, so it goes. And there is a great resource here. So someone is really putting a lot of effort in trying to keep it up to date. Here is the address. If you want to see some other, let's call this like prompt engineering techniques, You know, even if you're not into mathematics or computer science, they are most of them are actually quite easy to understand. I mean, because they are something you could think even people doing in some way. Like here in this specific example, it's if someone asks you and you're under extreme time pressure and you just need to answer immediately, you would of course often be wrong, or especially if it is the kind of problem that does require a bit of thinking, and simply, you know, kind of trying to slow down a bit improves the results. But I've also added this example here simply because now a lot of people are saying that prompt engineer, that this is a new profession of the future. And I mean, in some way it is, I guess, but I think it's only temporary. So what is this about? So the question is, okay, if we found this, let's think step by step, how do we find something maybe even better? I mean, because it's so chaotic. How did they come to this idea? Let's think step by step. Somebody just remembered this, and I mean, and they tried and it worked. So what the authors did here is, and I've included this since it's kind of a nice description. So basically, they just gathered a data set that had these questions similar to the ones that you saw on the previous slide, right? And now that they knew that let's think step by step works, they use this first let's think step by step to find not just the answer, but the reasoning. And since this was a data set, they knew what the correct answer was. So they only, you know, they cleaned it up and they just kept the ones that led to the right answer. And then they basically they deleted the in-between part, so that the prompt, and then they just tried to insert to use another language model to generate just candidate prompts that they did limit themselves to starting with let's. And you know, the result was that they found something something even better. And it's like, let's work this out in a step-by-step way to be sure we have the right answer. And they passed the accuracy. I think it was like 81% or something compared to this 78. I mean, it's not much, but it's interesting here because in some way the model is improving itself by practicing this, you know, generating examples of this chain of thought thinking. Now to talk a bit about the code. It's a very controversial area in some respects. So the development in this area, at least when it comes to these language models, went that first OpenAI kind of launched this family of codex models, and based on that, Microsoft, or I mean GitHub, offered this product Copilot, which is still being used. But then, of course, there are quite a few open source solutions now available. Basically, models that, in some cases, they were also carefully trained on data sets which have permissive licenses. And here I'm including some results just for comparison among different models. This Chinese one was the last, and they said that at least on some data sets they achieved the highest accuracy. To me, it's also interesting this slowly trickling evidence about you know, how effective these things are when it comes to productivity. Obviously, this study was done by GitHub. They have skin in the game, so maybe it's a bit it's worth to be a bit careful about it. But they did find quite a big increase in productivity, and also I kind of monitor a lot, you know, these opinions, and at least I would say, not that it's really strong evidence, but anecdotal evidence is kind of favorable to these models providing a bit of value. Maybe just to give an example. So I'm again going to show something that possibly can be useful due to the prompt itself. So let's go with this chat and let's reset it. Now let's start simple, right? So write a program to determine whether prime number, whether a number is a prime. So it's not a very, of course, one would say, you know, surely it memorized this, right? So whenever you have this type of situation, it's also nice that it provides the explanation. Like I said, for tutoring, it's very useful. Okay. Okay, but one, let's say, like magic word here is now make it run faster. I mean, you can. I tried, and you can push it. I mean, the code gets progressively stranger. Also, of course, there's more likelihood, more likely that something will be wrong. However, it does remember some special, like mathematical approaches to this, and it's able to optimize and so on. And yeah, now I have another one, and you know, because that other one is from more like a startup company. They are using underneath the same models, but taking a different approach a bit. Let me see where it is. All right, so it has a very simple interface. So it's it just asks you what language is this program written in, and that goes Python. And what will this program do? Let's do kind of converter, convert PDF file to Markdown. I did something like that not long ago. So okay. So one thing that you can now do is you can take maybe one output. I do. Maybe I should copy it, right? Like this, copy. So and you can put it here, and this code. Okay, what needs to be improved? And then it just goes on and it tries to do the updates. I don't know. Who knows if this will work or not? I'd rather not try. But yeah, I mean, I just more or less I wanted to demonstrate the principle, right? It's similar to that chain of thought thinking from before. The models, if you give them this reflection, or maybe you know, use one instance of the model to exert some control over another one, and it isn't a perfect guarantee, of course, and using these models, of course, is risky and requires careful testing, like all of the development, but still, we did reach, I feel, with these latest iterations, a kind of an interesting point. I'll also mention this. So there's a common problem with use of these models is that people say, you know, but how good am I at writing the instruction initially? And, you know, the models are not following my direction, or I didn't want it to go this way, and so on. And there's a nice trick that someone found. It's very useful, not just for code, even if you're using it for writing. It's So, when you are writing these initial instructions, for example, you can just like write these shorthand descriptions or ideas how the flow should go, and the model is able to take this and it kind of it sets the roadmap. So it doesn't need to decide on its own the whole direction, but it follows a general direction, but it fills out, for example, a lot of boilerplate code or things like that, depending on the use case, right? Yeah, so they mentioned this profession of prompt engineer. So this person actually just now has started a job as a staff prompt engineer. So it's, I guess, one of the early people to hold this, and he really knows to find like nice properties of these models. So well deserved, I would say. Yeah, so one other thing that I wanted to mention, and now I will move slowly a bit also to the search aspect, since it's quite important, I think. So recently a model was released, Whisper, which is basically it's used to do speech to text, transcription, but also translation from various languages to English. It's totally open source. And I feel that it has a lot of value for many use cases. I mean, maybe to most or some of you, it doesn't sound that exciting. Why speech to text? But it works really well. So maybe, and now I can also show you a tool that is based on it. Just a moment for me to find it. Yeah, so some company built a model podcast transcriber. So here, basically, you can search across different podcasts. There's one I like to listen to, so Superman Lab. Yeah, it's this one. Kind of about neuroscience and health. I do recommend it. If you don't know it, you should check it out, I think. So basically, here are all the episodes, and some have this icon beside them and some don't. So the ones that do have already been transcribed. So let's maybe go to an earlier one. I don't know, like Master Your Sleep. Now on the slide previously, you saw that I said like it takes kind of like half an hour for a 2-hour podcast or something like that. But here, this website is built in parallel, so it will actually be quite quick. Yeah, so maybe while it is being done, just where is the significance? So what we are seeing now is the different ways of expressing ourselves are kind of merging. So previously, if something was recorded and there was no transcript, there was considerable effort in trying to provide this transcript, and so often, or maybe even most of the time, it wasn't. And also, we did have software that did something like that before, but it, not very good, at least not very readable, I would say. And this one works much better. So, I mean, these different modalities are starting to merge. And so this means that for all kinds of search algorithms, all of these will become very discoverable, right? So basically the transcript is done. So now it is searchable. And this is the example basically that I also wanted to show you and also to discuss this a bit. So now with these foundation models, we are getting the ability to do true semantic search. So basically, semantic search, for those of you who might not be familiar, is the one that is done according to like the meaning of sentences of paragraphs rather than simply their syntax. I'm afraid that like most of the experience with search that we have until now is just more or less syntactical, sometimes with some like page rank algorithms or things like that. So what we can now do is we can take this text and we can use the language models to embed it in a semantic space, and use it to search. And I did this with another episode that I transcribed about coffee, and just let me find where it's open. Yeah. Oh, this I've used the template is for another bot, but here I can. The podcast episode was about coffee, and like I can ask it like when is the earliest time that you should drink coffee, because this also really goes deep into the science behind it. Right, and I listened to this episode, so I can confirm that indeed he says that. Now, imagine if you scale this type of thing to other domains and maybe like company knowledge bases and things like that. So I wanted to show you some of the search engines that are now emerging. So this is a very new search engine, and you will see kind of combination of this semantics, but also of using language models to summarize and even provide sources, because this is again one big issue for them. If they just summarize something, we don't know exactly where did this come from. Let's ask it about this model. So what is up with ChatGPT? Right, so you get a brief result. Chatbot, OpenAI, expected to follow next year. Biased, okay. And for each one of these statements, it provides a citation. So I think it's really nice. Now for another one, and this actually I would say this is my favorite out of these new search engines. So here you write a prompt in which you describe what kind of website would you like, and then it follows with the actual website. Very nice examples can be found. I mean, I shown this one multiple times, so it's getting a bit old, but still. Let's say that you find some interesting word to describe a certain hotel, for example, like a Turkey hotel in. No, you get the right idea. This is a home page of a quirky hotel in Spain. And I don't know, maybe we'll be lucky, maybe not. Oh, it does look a bit special, not too much though. But one difference that you have here is, the first result was not some commercial aggregator of something. It was exactly what we said. Like you want a homepage of a certain hotel in a certain location, and this can also work for technical tutorials or things like that. So it's a different approach to search. But now you did spend quite a bit of time. So I do want to touch upon images because they are also a very important topic. So I will go from two directions, and so we still have a bit of time. So first of all, I feel that one of the biggest values from GPT-3 in connection with the image generation models is you can use it to instruct the text models to come up with very interesting ideas for visual generation. So here I will just show this example. So you say that you want to generate various kinds of imagery, and you give him an example. So let's say fashion photo shoot, and provide some detail and the format. So how is this type of image usually described? But then you ask it, okay, so now provide other types of images. And so it will, hopefully, it's slow today. Right. It came up with something. Oh, he still owes me 2 more. I said 8. Okay, now we did 10. So, and I can just say now provide. Now you can ask it to provide you a template, but let's just take, I don't know, let's just take one description and put it into one of these image generators, which I must have in another browser. Oh, there. So this is the latest version of the Stable Diffusion. Okay, so and then if you want to have an image that is a bit more artistic, usually it's Midjourney that's a better candidate. So another one of these models. Where is it? Oh, sorry, I managed to close it. Anyway, maybe so we don't lose time, it would be good to have a bit of a discussion as well. So I'll, I don't know, maybe we can have some questions if there are any. I wasn't looking at the Q&A. Oh, quite a lot. So let me dive right in. Okay, so yeah, the slides, of course, but I think that Blaž already mentioned that. I did enlarge fonts. Hopefully it was enough. The URLs, yes, I will try to add some of it. Yeah. Yeah. Okay. So this is from Milorad. What is the future direction? Very very important one. So now we are. I feel that we have reached a point where these things have become commercially very interesting and very viable. So I expect a lot of VC investment in the near future. Also, more and more companies realizing that they can apply these models. But we are now in the period before GPT-4 comes out, which is very much expected, and a lot of speculation abounds about its capabilities. So possibly one scenario is that this model will out of the box be able to do some tasks rather than just give you text, right? So that I did show you like small prototypes of how this would look like. So the AI becoming more agentic rather than just responding to our queries or things like that. Also, maybe it is kind of speculative, but still, it does. I will go to my last slide. Obviously, I have quite a few, and I will share this. So it's a bit short on time. So yeah, one thing I wanted to share was that if we look at the predictions for this artificial general intelligence, I mean, it's kind of defined here as a weak general artificial intelligence because it's just defined to achieve certain results on the diverse benchmarks, but interesting how people were estimating this on Metaculus. So this is like a prediction market, and in January of this year, the forecast was that the AI systems will reach this level of performance in 2042. But then all of this happened with images, and we realized that some things are easier than we thought. Now prediction looks quite differently. I'm sorry. It's currently it stands at 2027, which is less than 5 years away. We'll see how it goes. The track record in the last 10 years wasn't the best in terms of people were usually, except in a few rare cases, more pessimistic about when a certain performance will be achieved. Oh yeah, to also to mention that, yeah, chinchilla. So initially these models were, let's call it a bit misestimated. So those scaling laws that I was showing you that were falling linearly, there was a bit of a misconception there. And later on, in DeepMind corrected that, and the realization was that actually, in order to further increase the performance, we might not do so optimally by simply scaling the parameters, but we should train the models longer on larger amounts of data. But since a lot of the public data was already absorbed in these initial trainings, now I guess it is a bit of a race to discover alternative sources of data. So I would say companies who have extremely large internal text databases have an advantage, and also this might be related to why this speech to text efforts are suddenly more interesting, because this is also one way how to produce additional text. So for Armin, did I stop the bot? So basically what happened was that the bot was waiting for the call to the API to be answered. I think this is the pause that you saw. The problem is now that the ChatGPT is so popular that even the regular API is working a bit slowly these last few days. So usually it didn't take that long. Regarding the resources, I feel that this is actually the perfect time for someone who is not a programmer or a mathematician to enter this field, because in some ways it's still early, and a lot of the things that we learned painfully down the road are suddenly not maybe that relevant, like some of us maybe hope that they will be for still a long while. So I think that interacting hands-on with the technology is extremely useful. So if you take one thing from my talk, is please do try, especially this ChatGPT. I think it's really good, and you will immediately get a much better insight into how well does this technology perform, as if I was trying to show you some things here, or if you just read some blog post or something like that. Oh, and I should say that if you want to really keep close track, then actually Twitter is the best resource. But one needs to discover who to follow there, and to not enter into flame wars with anyone. Yeah, when it comes, yeah, I mean, Endava has internship programs for juniors regularly. I don't think we have one open now at this very moment. However, this will probably change in not too distant future. So But still, it's always, I guess, a good idea to reach out, and we can see on the individual basis how things stand. But yes, I mean, I see Endava really as a company that's very open and welcoming to people who have just finished their studies, or maybe sometimes even if they are just in the process of finishing them. Thank you, Micha. I mean, it's you know, it has become much easier to give nice examples because it has grown so powerful. But you know, still, maybe I will be able to find. Here it is now. I found it. So maybe I can also show you Midjourney. So it's quite different, and maybe some people get, I don't know, maybe they see this and get a bit scared, but in fact it's not. So Midjourney is organized differently. So it's in a Discord channel. I mean, I still frequent this channel for newbies, and it works like that. That basically you have to enter a channel and you have to instruct a bot with the model to draw you something, and it's very easy. You just write imagine, and then the text. I do think, yeah, I still had it copied. And then it's very important, if you want to get the better model, you just do like --V4, which simply tells you to use the latest model, not because if you didn't write that, it would use an older one. And then you have to wait a bit, not too long though, since it's a bit of a queue. Personally, Midjourney currently is my favorite image generator. It really produces incredible results. So okay, so now it started, but you know, you see first it's a bit lower resolution, and then it will improve quite quickly. And then after it's done, you get basically you get asked whether you want to do a variation of this, or if you want to upscale to a larger image. I don't know actually why it didn't ask me now. Probably because I'm showing this as a demo. I mean, it's also very instructive to frequent this because you also see the prompts that people are writing, so it can be educational by itself to hang out here. But if you are, you know, if you want to see both like the images that are being generated by these models, but also to get a grasp of how good this semantic search is, I recommend this website, Lexica Art. So here, basically, you know, it's a kind of a aggregator of all kinds of images generated by these models, and you can search by text, or you can just find an image that you like. Let's let's do this post-apocalyptic car. And now that I've clicked on it, it will give me also, you can say like explore this style. I think it's like that. It will try to find similar, right? So you see, it's this semantic similarity on images is working really well. But now I remembered something. Maybe it will be the last thing that I show. We'll see. I have too many links, I guess. So just so I find it. Yeah, I found it. So there's this store in, I think it's in South Africa, that is selling like things for home and also for clothes. And then someone actually implemented a semantic search over this store. So simply as a hobby project. And it gives you a nice idea how like some of the future e-commerce search might look like. Like, let's say I go man, and I mean, I don't need to search by I don't know, by let's I don't know, let's put Gandalf. Right. Let's see, find something. Okay, maybe not the best example, but I guess the color is more like it. So, or let's do let's do like 70s fashion. I already tried it. So. Right, and it's quite likely that none of these clothes were, they were labeled as being in the 70s style, or it works the same for furniture, I guess. So maybe it gives you a good impression of how these two worlds of images and text now are becoming totally intertwined, and soon obviously we will also add video and speech, and it will be a kind of like multimodal AI universe. Yeah, of course. The question in production is always. So I will I will tell you a few of the things that I feel are the most low-hanging fruit. I feel that simply making information in companies accessible, easily accessible to everyone, is something that can be a huge time saver and generator of value, and it is rather easy to do. So, I mean, if we are not talking extreme amounts of data, simply taking what is accessible and semantically storing it in a special database and then building chatbots over that, I feel that could provide really a lot of value. Then obviously, when it comes to productivity, making, us needing to do less work that is slowing us down is always nice, whether it is, in coding or doing some internal processes and so on. But then, it's one important thing with this technology is when you say in production, it doesn't necessarily mean the same thing as it did with previous iterations of machine learning, because machine learning in the past used to mean that you needed very complex architecture and, I mean, infrastructure, a lot of people training models and so on. It was complicated. So here, there are many use cases which you can implement in your daily workflow and don't require a significant investment either in skilling or, imagine that if you have something that looks over, the error messages that you get and provides some advice, it doesn't have to be a very complex project. So I think a lot of these projects might be very effectively implemented as long as the use case is chosen well, so that we're not talking. I would maybe avoid use cases for now that would require a lot of bot human interaction, especially like bot customer interaction, because there are so many other cases where you can provide value, and the best cases are such where making a mistake here and there doesn't cost anything or a lot, at least. So like self-driving cars are a very bad example actually for use of AI, because if there's a mistake, you can die, right? Here, if you get a suggestion for a wording of an email that's not like exactly to your liking, or maybe contains something silly, and the rest of the 99% of the time it works okay, it's not really a big problem that would prevent this going to production. Yeah, so we are, I think, at about the end of the talk. So thank you all for joining me. Happy to discuss this topic. If someone reaches out, it's a big interest of mine. Sorry a bit about the chaos. I really have many of these things open, and whenever you are even running code alongside it, it can become interesting. So thank you, and see you at some other talk, I guess.